For the written report, I chose polylactic acid, also known as PLA. The written report focuses far more on how PLA is made and what its properties are. It goes a little bit into its uses, but this video is going to be focused on the real world applications of this plastic and how it's actually used. But before going into that, what is PLA? PLA is short for polylactic acid. The molecule of lactic acid, which is not polylactic acid, looks like this. This model was taken from the National Center for Biotechnology Information, and whenever I reference a source, it'll be shown on the bottom right of the screen. Essentially, if you get enough of these molecules in a chain, it creates a very strong material known as polylactic acid. These are all just fancy words for plastic, pretty much. So PLA is just another type of plastic. This plastic is actually used a lot in 3D printing, but why? This plastic has a low melting point, it has a really low glass transition point, it's quite brittle, it can't hold up to ultraviolet light either. But there is a really good reason why people use this plastic so often in 3D printing. This printer is actually in my room right now. It's printing something and I can definitely smell the fumes coming from it. If this plastic were ABS, it would smell pretty strong and it would probably give me a headache. PLA, when it's burned, smells like candy. Actually, it smells really sweet and it is non-toxic. When PLA burns, it releases lactide. Lactide can be considered an irritant, but you're not inhaling enough of it to actually burn you. There was actually a study done by the Southern Research Institute in Birmingham that actually tested on dogs. For 14 days, they gave each dog a capsule of lactide. Some of the dogs received massive amounts of lactide and others received none. Some dogs received 2.5 grams of lactide per kilogram body weight a day. That doesn't mean that they receive 2.5 grams. That means that they receive 2.5 grams for every kilogram. So for example, for me, that would be over 180 grams. They state that all the dogs survived and some of them did receive small burns in their esophagus, but that was only in high concentrations. They found that under 100 milligrams per kilogram body weight a day, they couldn't record any adverse effects at all. For me, that would be equivalent to about 7.2 grams. That doesn't really mean anything for inhalation, but generally it's considered safe. Another reason that PLA is used so often is its affordability. If we want to find out the cost of PLA, we can actually go to a retailer like Amazon and just type in PLA. PLA is sold in spools generally, and it's important to remember that these spools do not reflect the price of the actual material, as there needs to be tight quality control on the filament diameter. The filament diameter generally needs to stay within 1.75 millimeters, otherwise it could jam printers, and that can increase the price by quite a bit. The price can also increase through different retailers, such as Prusament, which is a brand name. The price can even be increased through different additives, not particularly dye, but things like marble. Marble can increase the price because the marble itself could cost more, or it could just cost more to produce it. But generally, PLA is a cheap plastic. Hold on, what is marble PLA? Is that just a dye, like painting your house walls eggshell white? It's actually marble. It's really made of marble. Now, it's not all marble, of course, and it's usually only 20% marble, but it is marble. You can actually do this with anything you can grind into a powder. However, it actually does make PLA significantly weaker and harder to work with. There have actually been some studies on adding different powders to PLA. For example, here's one study from Chemnitz University of Technology in Germany. They add 3 different additives and compare their strengths. They add magnesium, iron, and polyethylene. Here's the 4 compared to each other. The one on the left is 100% PLA, then it goes to 5% polyethylene, then 5% magnesium, and 5% iron. They show some of their equations and how they got their answers, but more importantly, they show a figure of stress and strain. So depending on the additive that you put into PLA, you can change the properties quite a bit. For example, the PLA and iron composite lasted longer before necking. Compare that to, for example, PLA and polyethylene, and it didn't last quite as long. They show a zoomed in image of the composites lower down. They explain in their paper why they think some of the properties were the way they are. They think that the reason polyethylene wasn't as strong as the other materials was because of their difference in polarity. This reduced their adhesion and made it easier to snap. They talk about the thermal properties too, which is actually actually incredibly important for 3D printing. PLA has a very specific melting point, and it's important to get that right. Before leaving this article, it's important to remember that they didn't consider the cost of the materials. PLA with iron mixed in is quite expensive, and it's not logical to use it in every scenario. If you want a cool effect though, these composites can be perfect. For example, here's a bust of Julius Caesar that I made out of marble. He has holes in his back to be used as a pen holder. The texture really does look like marble, and to a degree it almost feels like marble as well. It is important to note that I didn't make this model, and if you're not good with 3D modeling software, you're probably going to have to find them from a website. I did, however, make this model of an anvil. This is just the model, but I actually did print it out. In fact, I used a metal filament to print it out. Here's the metal anvil. It's not actually metal, though. It's really just plastic with bits of iron mixed in. However, being mixed with metal makes it pretty heavy. It actually makes it magnetic because it's mixed with iron. But the most interesting thing about metal filament is that it can rust. Yeah, this is a plastic that can actually be rusted. If we wanted to see it rusted, though, we could leave it out, but that could take a long time. Rusting a metal, though, is actually pretty easy. You only really need salt water and vinegar to rust the metal, but in my case it was taking kind of long. So to speed up the process, I used 12% hydrogen peroxide and a bit of heat, and it rusted within about a day actually. Here it is after leaving it in salt water and vinegar for about 2 weeks. After the 2 weeks, I got pretty impatient and I put it in 12% hydrogen peroxide. Here it is only after about 2 days in hydrogen peroxide. I actually damaged the anvil myself with all the scratches and the dents to make it look a bit older. I also filled it with sand to make it quite heavy. So to conclude, PLA is lactic acid that's connected in a chain. PLA is the most common filament used for 3D printers. PLA is quite cheap, and finally additives could be put in PLA to give it new properties. PLA is a pretty cool material that fits a niche quite well. Maybe one day this material will be used more often when it becomes more economically feasible to replace things like cups. But for now, PLA is primarily bought by hobbyists at home for 3D printers.